We are now going to be graphing transformations of sine and cosine. So before we graph, some things you should know is a basic sine graph, these are the main 5 points that we plot. And then we just repeat the shape over and over and over again. For a cosine graph, these are the main 5 points that we plot, and then we repeat the graph over and over and over again. All right, we're not going to just be plotting basic sines and cosines. I have equations like this for you to graph. So for these, I need to remind you of the transformations. A, b theta, or bx plus c, and plus d. How do those transformations change these coordinate points up here? You would divide by b and subtract c from anything that's in your x. That's why a lot of times we write an x here instead of a theta to remind you that these go with your x values. And straightforward, multiply by any a's and add on any d's to your y values. It sounds a little confusing, but it's not bad. Let's do some examples. All right, let's graph by hand y equals 4 times sine x. Okay, so we take our basic sine function. There's a 4 in front of it. That's an a value. So I'm going to take these coordinate points and I'm going to use my x value straight up because there's nothing in here with my parentheses. But I have a 4 in front of my sine, so I'm going to take these numbers here and multiply them all by 4. All right, 0 times 4, 1 times 4, 0 times 4, negative 1 times 4, and 0 times 4. Those are the 5 points that I'm going to plot. So 0, 0, pi halves 4, pi 0, 3 pi halves negative 4, and 2 pi 0. And I could continue on the curve. There is my graph. See, that wasn't so bad. Let's do another one. All right, this one's got a little bit more going on, but still not bad. We are at our sine graph, so our basic sine points again. Can you see that? And this time we have a negative 3 in front of our sine and a plus 1. Remember I told you if you don't see parentheses, this is implied to be a d value. So there's nothing in my parentheses with my x, so that's going to stay as is. But I'm going to multiply negative 3 times y, and then I have to do it in 2 steps just so I don't make any kind of careless error. So then I'm going to add 1 to whatever that was. You can do it all at once if you want. It doesn't really matter. I just make careless errors really easily, as I'm sure you've noticed. So negative 3 times these y values, and then add 1. I almost made an error again. So I'm going to plot these coordinate points here. So 0, 1, pi halves negative 2, pi 1, 3 pi halves 4, and 2 pi 1. And I could continue on plotting if I wanted to. And there's my graph. It has been flipped upside down, stretched 3 times taller, and the center has been moved up 1. Let's do a cosine one. It doesn't change. The rules don't change here for cosine versus sine. We just have new starting points. So for cosine, these are my starting coordinates. All right, again, I don't have anything inside my parentheses, so my x is going to stay as is, but I have a 1/2 in front of my cosine. And I'm going to do it in 2 steps again. And once I multiply by 1/2, I'm going to subtract 3. So my x's stay the same. And then multiply each one of these values by 1/2. And now subtract 3. Oh gosh. I do better with decimals, so that's why I had to switch it real quick. All right, and I'm going to plot these values together. So 0, negative 2.5. Pi halves 0. See, stupid, careless mistake. 0 minus 3 is negative 3, not 0. I hope y'all would have caught that in class. Done. Notice my center of my graph now has been moved down 3 and not quite as tall. All right, let's do an example where we finally have a transformation with our x's and see what happens there. So we have y equals sine of 4. We're going back to sine, so make sure you start with the correct starting points. All right, 4 is in here with my theta, or sometimes we use an x. 4 is in here with my x, but we can't go straight forward. Anything inside your parentheses has to be backwards. So I'm going to take my x values and divide by 4 instead of multiply by 4. I don't have anything multiplied in front or added to the end, so my y values are going to stay as they always are. We're using these. All right, 0 divided by 4, pi halves divided by 4, pi divided by 4. Ooh, this is going to be fun to plot. But we can do it. All right, 0, 0, an eighth, 1, a fourth, 0, 3/8, -1, and pi halves. There we go. This is our whole entire graph. We're just going to repeat that shape. Wait, the whole thing fits in? Yeah. This is a pain to draw something so small. But we got it! It's been squished in 4 times smaller or tighter than normal width. Let's do another one. All right, again, we have a number in here with our x. This is 1/3 times x, or x divided by 3. We could have also written it like that. It's the same thing. So when I do my transformation, we have to be backwards. So instead of dividing by 3, we're going to multiply everything by 3. And there's nothing multiplied in front or added to the end, so y stays as is. All right, 0 times 3, pi halves times 3. Oh, that should be a 2. This is definitely not going to fit on our graph, but it's okay. We'll get the picture. Okay, so 0, 0. 3 pi over 2, 1. 3 pi would be somewhere out here. Okay, so this is, we only have room for like half of our graph here. But that's what it is. It's so widely stretched out that it doesn't even really fit on this. But you get the idea, I hope. We can also add and subtract, deal with c values. We haven't done anything with a c value yet, but remember it's the same exact thing except you're going to do the opposite sign here. So instead of adding 5 pi over 6, I'm going to subtract 5 pi over 6, and it is in there with my parentheses with my x, so that reminds me to do it to the x, not to the y. So 0 minus 5 pi over 6. Oh, we need to get common denominators here. Negative 2 pi over 6 is negative pi thirds. And my y values stay the same. Okay, so negative 5/6 would be somewhere way past here. That's off my graph. Negative pi thirds would be somewhere between 0 and 1/2. Pi 6s? I really am bad at estimating without decimals, so 2/3. I think this is what our graph would look like. I'm not going to continue that because that's really hard. But it has just been shifted to the left. It took my graph and moved it way back. So this is where I would have started. So this is our normal shape, and it got moved backwards to the left to make this new shape. You can tell these are my least favorite ones to do. All right, let's do some crazy ones that have everything going on. We're going to graph y equals negative 2 cosine theta plus pi halves minus 3. Okay, so inside the parentheses, happens to my x values, and it's backwards from what you expect. And outside, I'm going to do this in 2 steps for my y's. Okay, so I need to take all of these values, and way easier, let's subtract pi halves. Much easier. All right, and then take all of these values here. I hope you can see this. Multiply by -2. And now subtract 3. And this is what I'm going to graph. So negative pi halves, -5, 0, -3, pi halves, -1. I can continue on my graph because this one was easier for me to figure out. So it was flipped upside down, moved backwards, 2 times taller, and the center was moved down. But there is my graph. So what you're doing is just taking these basic points, and anything inside your parentheses you're going to divide by b or subtract c, and anything outside of your parentheses goes straight forward times a and plus d.